In today's lesson, we're going to be taking a look at the development of a parametric mass in the conceptual design environment. We'll look at techniques for dimensioning forms and working with labeled dimensions, and also how to use parameters and formulas to control the final appearance of our mass. There are two basic workflows that one can follow when generating a conceptual mass. The first option, which we've covered in the last few classes, is to create an intuitive mass which will usually be developed from model lines, often as an in-place family, but not necessarily. Forms based on model lines are unconstrained and lend themselves more easily to direct manipulation. It's also possible to create an intuitive mass in the family editor as a loadable mass family, and have the final shape modified directly by pushing and pulling on faces, edges, profiles, etc. The second approach one can use in developing a conceptual mass is to use parameters and formulas to mathematically define and drive the size and shape of the final form. This approach is best accomplished in the family editor, where it's easier to view and work with reference planes and levels, and also to create labeled dimensions and other parameters. If I take a look at this project, this is using a loadable mass family that is parametrically controlled. And if I select this mass, we see that we have some properties and parameters associated with it, which I can use to modify the shape. This WCPL constraint value is a width change per level set to 3 feet. If I were to change that to 5 feet and then apply, the top of my tower is going to get smaller. And if I want this curtain wall unit or curtain wall system to update, I can just choose Update to Face. And it's going to follow that new increasingly tapered shape. Let's just remove the curtain system for now, and we'll take a look at that again. So this tower is being controlled by a number of parameters, and we can change another one here to reduce the overall height. This is a height per level, and if I set that to 30 or 50, we can drive the shape. The angle per level is set to 10 degrees, and that's creating the twist. But if I were to change that to 5, we can reduce the amount of the twist. And we can also reverse it to have it going in the other direction. The geometry for a parametric mass is usually developed from reference lines instead of model lines. The reference-based forms cannot be intuitively modified as easily as unconstrained forms created from model lines, but they usually respond more reliably to being parameterized. Let's take a look at another parametric mass. And this is one of the default masses that's included in the mass family category. And this is also a parametric mass. This is called a gable mass. And we've just opened this from the Imperial Library mass category. And there are a number of different primitive shapes, such as boxes and cylinders, all which are parameterized. This particular example includes properties for the width, the height, the eave height, and the depth. If I were to drop this to 20 feet for the overall height and apply, that's going to give us a lower pitch on the roof. If I go back into my model and I change the depth here to 60, we can see that this is centered on the origin. It increased in length in both directions. And this is being modified. Now, if we were to take a look here in the level 1 view, we can see where these parameters are coming from. And here we have a labeled dimension for the width and the depth. And if we go to a front elevation view, this mass is also including a couple of parameterized dimensions here that are referencing these reference lines, and then the geometry itself is locked to those reference lines, being driven by these parameter values. The geometry for the masses that are in the mass category are all model lines, but if we were to take a look at our tower, and we select this one and we edit this family, switch over to our 3D view, all of the geometry in this shape is being generated by reference lines, and you can see the reference lines being highlighted. And each of these reference lines are actually associated with a reference point, and the reference points have angles associated with them that are driving that twist for this family. Reference lines are especially useful for controlling angle parameters such as the twist or the rotation angle for a blend form. If you add a reference line and align one of its endpoints to the origin of the two main reference planes, the other end can then be rotated in any direction, and an angular dimension can be added and then labeled to control the rotation angle. Let's take a quick look at that option. I'm going to choose to create a new conceptual mass. I'm going to create a reference line, so I'll choose the reference option first, and that's going to start my reference line segment, and I'm just going to draw this in at the intersection of the two reference planes. The length doesn't really matter. And then I'm going to use the Align tool, and I just want to lock that in to this reference plane and to this reference plane. And now I can rotate this in any direction, and I can host geometry on this. So if I bring this down to 0, and then I use my Set tool and I select this reference, now if I draw a shape, let's just draw a rectangle here. If I were to select my reference line and rotate it, it's going to rotate that rectangle as well because this is hosted at that point. If I create a new level and then I select the reference line and I say that it's going to be associated with level 2, it's going to move up to that level. It will adjust with that level, and it's going to take its nested geometry with it, and we can still access this and rotate the rectangle by rotating this reference line. The reference line itself can now be parameterized by adding an angular dimension. The reference lines can be hosted by levels or other reference planes, and the reference lines themselves will define 4 reference planes. One of those planes can be set as a host for further reference geometry, which will be created to define the form. And in this case, we drew a rectangle that is a model line, but we can set that to be a reference line as well, just by choosing the Is Reference Line option. So our reference line can host other reference geometry, and then this other reference geometry can be used to develop a form. And that's going to be controlled by this angle. The dimensions for a form can be set a number of different ways. In the intuitive massing workflow, forms are manipulated and resized directly using 3D controls on the faces and edges. So we'll just select faces and drag them until they're in the right place. But in the family editor, it's also possible to add permanent dimensions to conceptual masses and then label those dimensions to create length or angular constraints. This can be done by converting temporary dimensions to permanent dimensions, and then selecting those dimensions and adding a label. And we'll say that this is the height, and we can set this to be either a type or an instance parameter depending on how we want to be able to modify it. And now if I go into my type properties and we drop this height to 30 and apply, we've created a parametric height on our mass. If we want this angle to be controlled parametrically as well, we can draw an angular dimension in here, and then we can label this one, and we can choose to add another parameter. This is an angle type that we can group under dimensions, and we'll just call this a twist angle. And then pick OK. If we go into our properties here, we can adjust this to 15 degrees and apply. Whoops, 15 degrees, not the height, and apply. and we're going to be able to rotate it around. Dimension parameters can be defined on the fly by adding dimensions and then choosing the Add Parameter option in the Label pull-down. But if you plan your mass in advance, it can sometimes be easier just to open the Family Types dialog and create the majority or even all of the parameters before you start drawing any geometry. So we can set up a length and a width as well by going in and changing or adding a new length parameter. Set this as an instance and group it under dimensions. We can add another one called width. Set this as an instance and pick OK. And let's just set some values here. We'll say that the width will be 20 and the length will be 40. Let's set the angle back to 0 and apply that and pick OK. And now, if we select this form, we can associate dimensions with the underlying geometry as well. So I'm going to just do a tab select on this geometry here. We can choose to activate its dimensions, and then we can create permanent dimensions based on those objects, and then we can associate these, and we can say that this will be a width, and this one is going to be the length. And now we have 4 parameters associated with our box. If we want this to be centered at a certain location or centered on the origin, then we will create some equal dimensions to do that as well. At the moment, this is going to be defined with its origin at the lower left corner. That's enough for our basic dimensions and labeling of masses. Next, we're going to take a look at creating parameters and formulas in our conceptual masses.